Okay, before we get into this video, I just wanted to get on here and say I hope everybody had a great, healthy, and wonderful Thanksgiving. We got Christmas coming up. I hope everybody has a great Christmas as well. The reason I'm coming on here, I want to tell y'all I'm thankful for everybody and everything you guys do and just watching the channel. And also we're going to have basically a Vlogmas going on. I guess that's what they call it. I have a monumental amount of scrap to get through in the next basically 2 weeks, 2.5 weeks, something like that. My scrap yard in Miami closes the day before, or a couple days before Christmas, so I need to blast through as much as I can before that, as well as all the other stuff going on in my life. We have a lot to do. So on that note, I hope you guys enjoy the motor madness that's been going on. As you can see, the table is just about cleared. We got all the big boys out of the way, and got a decent chunk, which you'll see here in a minute. So hope everybody's happy and healthy, and I hope you enjoy the videos. There we go. That's interesting. You gotta pay attention. Look at this. It's got a bunch of pins here. That'll cause problems with this trying to shear it. So that particular one will have to basically cut one side and pull it. Now some of these smaller ones, I actually think that's the way to go, because that's really small to shear. And it's really not worth, you don't have to shear it. I don't like cutting it because you're creating dust and you're actually losing a little bit of copper. But I believe on these really thin metalled ones, that's the way to go. See, some of these also, it's like, there's nowhere for the plasma cutter to blast through. It's a very small, fine line. Okay, we gotta ramp this up a little bit here. Alright, that's not bad. I need to go turn the fan on. It's kind of chilly out here, man. I don't want to turn the fan on, but I don't want to be breathing these fumes either. Some of them got a flat spot. That's the way you do that. Some of them have just a round spot. Some of them don't have nothing. That seems to be working out pretty good. Okay, I'm gonna go turn on a fan, and we're just gonna time lapse this because this is pretty much repetitive stuff. But even where it's flush, what I've been doing is I'm holding it on an angle the best I can, and as I cut, I wiggle it back and forth to kind of open it up a little bit. Seems like it's working pretty good. Now I might even put, you know, these, I might put them down on the ground there. Use the bucket of the skid steer and crush them. Flatten them out a little bit better. They're flat, tight. One, they'll take up less space. Two, it'll be easier to kind of put them in there with the prepared steel, you know? Now, we got quite a bit of prepared steel adding up over here, so we're gonna have a decent load of that stuff. Anyway, let's get all this stuff knocked out. I might clear that stuff off on the end of the table there, so I got some place to put this stuff, because I want to get them all opened up before I actually start splitting, because once I start splitting, I want to do them all, not just some and then come back and do that. Now this one here and this one, I don't think I'm going to be able to split. I'm pretty sure this one's got pins or something too. This one here, we might cut one side and cook it. This one, I think I could just knock those down. I don't know, we'll have to see. Either way, regardless of the situation, we're gonna get that copper out of there. Okay, so the plasma cutter, speed-wise, I think is the way to go, man. I mean, I don't think anything's going to compare to the ease at which that cuts through. And then another thing, you really got to look at these things, because not all of them have a flat spot in the actual stator, like that flat spot there, that flat spot there. If you can find those flat spots, it works so much better. And also having a ground works really good. That's it. Oh. I was blasting through these things like crazy. Now these ones are a little, this is a little tough. This one actually still has a aluminum ring on it. Cast aluminum. These really don't have a flat spot. They have there's one gap you can find. Usually all of them they'll have like a round hole or one spot. And the thing is, you needed to let the sparks blast through, otherwise you burn your tips up. I've been doing pretty good. This tip here, I cut a whole bunch of AC compressors with it, and it's still going strong. Now I did find the ones with a little bit of rust. The ones with a little bit of rust make a good connection on the table. I can leave the clamp over here for the ground, and I don't have to actually clamp it to it. If they're really new and got a lot of good paint on it, sometimes you gotta clamp it. I think what I'm gonna do is get a real coarse file or a rasp and have it on the table where I clamp this. That way I could just stick it on there and just drag it across it real quick. That way I don't have to hit it with a grinder or nothing like that. But this definitely seems to be the way to go. That one's got a bad ground. See if we can get this side to go. You can tell when you're cutting whether you got a ground or not. This plasma cutter, it'll cut for that long. Wait a minute. It'll cut that long, but not very good. When you have a positive ground, you can tell. See if we can't get this one to do it. One, it cuts so much better, and two, it don't stop. So we're gonna have a dedicated station for prepping, okay? Which this little thin stuff, I could probably use that little best arc. We are going to run it on 220. They definitely run better on 220. But I want to be able to do motors and have a dedicated machine on the AC compressor recycling machine. I really am trying to up my compressor game. But I got to up all this prototype equipment. You know, this is all in the prototype stage. And I had a buddy here looking at, you know, we're gonna come up with a game plan And next month, I got a buddy coming to put a lot of 220 in here. We're putting in a whole nother 100 amp service over here. So I'll be able to run the air compressor, the plasma cutter, a welder, or 2 plasma cutters at the same time, and not worry about burning up breakers. Or right now, I have that air compressor plumbed into my other 5-horse Ingersoll Rand, and the tank here. There's a tank right there. So 3 tanks. It cuts pretty good. I did all of them that first time, and then all of these. But now I'll have to go over there and swap the plugs, let that thing fill up, and then I can continue cutting. So we'll let that cool down, fill up, whatever it needs to do. We'll prep all these motors. We'll go as far as we can, and then come back and plasma cut. Now, I've seen the copper catcher was using like a air chisel with a steel, what do you call it, a sheet metal cutting blade. That seemed to work pretty good. I don't know how well that's going to work, like where there's no gap, you know. And definitely I don't think it's going to work on stuff like that. So either you got to grind it, which takes a while and you're wearing out a lot of blades, or the plasma cutter, man. I mean, you do have consumables, but as long as you're not letting it blow back in, and I've learned to, you know, cut the right way and look for the gaps and stuff like that. Spend a couple of seconds looking for the gap. Like, now this particular one didn't have any real flat spots, but what it does have, and you can see I tried to find it, but I was a little off, is it has a bunch of little grooves like that. That's what you want to find if you're plasma cutting. If you can get right on top of that, and you know what? I'm wondering if I put the plasma cutter on an arm. That way I could set these, maybe even have like a laser, find it and set this in a V that slides, and have the plasma cutter just on a something, you know, kind of like that arm. But for this, oh man, that's what I need to do. I need to make a station for cutting these cases. It's going to save my consumables. It's going to be more precise and fast, where I could actually just automate it. I got those screws from my buddy, those automation screws, and I could just run it on a cycle. Actually, if I do it right and I got a good ground on all the stuff, I could line up maybe 3 or 4 of them and just have the plasma cutter go right down it, and then while it's doing that, doing its cycle, I could be over here undoing these, or you know, doing another step. We need to automate this process the best we can. And my buddy that was just here looking at all my stuff and has some great ideas. He's an engineer. He's a full-blown engineer and builds automation processes for manufacturing. Now we are demanufacturing, so it's basically the same thing. But what I love about this guy is I throw him a bunch of ideas and he'll be like, oh, well, we could do it this way or this way. And I'm like, well, this way makes more sense. And, you know, like, I want to do this. This is what I'm thinking. And a lot of times, you know, I'm right on par with the way to do it and what I'm thinking. He has more knowledge. I mean, he's in his 70s. He's been doing this his whole life. He has more knowledge on the how to build the machines to do that, you know, and what the you know, the electronics and stuff like that. Oh man, dude, I just came up with a great idea, and wow, we're gonna automate this. We're gonna get this dialed in. We're gonna be able to do these motors so fast. And yeah, we got a lot of work to do. We got to tighten up over here, man. Anyway, I'm gonna get on these here. We'll see if we can't get these apart the best we can. Recover some of that cast aluminum. I'm wondering if I should just cut these things off. Huh. That's another thing. You know what we need? Actually, I'm not going to say it. I'm going to have to wait until I get it. Matter of fact, I have it, but we're going to have to modify it to do a specific job. As a matter of fact, it's something that I've wanted for a while. But what we're going to do is we're going to get a big one, or modify the one I have for a big situation, but we're going to make it like this press over here. We're going to make it be able to accept multiple jigs to do multiple situations. And we can put my magnetic vise on it. Oh, oh man. Okay, look at this pile of copper we got going already, man. I'm super excited. Now, here's the deal. These ones here, I'm on the fence with this size. I'm pretty confident I can cut one side of this and pull that out. This one for sure, I'll cut one side. That's just going to cut down on me setting up and pulling the copper out. Now eventually we're going to be so efficient we'll just split it, but these big ones will split. We got to get the machine set up and hopefully it's not damaged. Hopefully we can get a straight cut going. Oh man. Okay, so yeah, we got a lot of work to do. Okay, I'm gonna go back to getting these things knocked out and prepped. We got a nice little pile so far. We're gonna get all these motors knocked out. We're gonna pull this big boy. This big boy needs to be cracked. I thought I had one more. No, all these need to be cut. Okay. That's what I'm talking about, man. Look at that big old nugget. Another one of those with the little metal strips. I might pull them little strips up if I can. See how hard. Well, maybe not. That one was about half the thickness of that one over there. So it actually broke pretty easy. And also, I got an idea of how to make that break a lot easier. What's nice about this one is I got it to break on the top and the bottom in one shot. And yeah. Oh hey, it looks like I got a guide of where to start in the center. Look at them big nuggets of copper, man. Holy cow. Alright, well now we got a couple more ones right here to plasma cut. Now these are some thick boys. So definitely plasma cutter is going to be the way to go. Man, you're not touching that speed with a grinder. The only thing that would come close to that would be a torch. And I don't even think a torch is the way to go. Oh man, this one. This is going to be a tough one. It's really got no gaps anywhere. So we're going to cut it here. Man, that's got some big old nuggets of copper. Look at that. All right, man. Okay, well, it's my dinner time. I'm gonna go take a dinner. Oh, we did get some stuff for the goodie box. So I got a couple pulleys, different size shafts, some nice bearings I recovered, an eyelet, and some keys and some other little pick points. And this one I couldn't get the screw out, so I just cut the shaft. I can drill it out. It had two, that one there I couldn't get out. We'll let that soak. I'll just keep it just in case I ever, in, you know, dire need, I'll drill that out. And I could just re-drill another hole in it. It's aluminum, and tap it real quick if I absolutely need it. These pulleys are not cheap, man. There's a nice double pulley here. So I have a whole box of these somewhere. I'm just going to add to it. My buddy was asking me about them when he was here. I told him I'd save him. I think this one is what he was after. Adjustable and that size shaft. So we'll get that over to him. Put the rest of the stuff in the inventory. And yeah, what do you think about this, man? The cracker. Now that to me is the best way of getting these cast steel cases apart. Like I said, I'm not going to sit here and beat it with a hammer. A chipping hammer might work on this size. That one that was 1/2 inch thick, I doubt it would have. You would have been working it, man. I mean, it literally stretched my 55-ton press cracking that thing. But I got a great idea for something that's going to assist in cracking these things going forward, and we're going to implement that. But in the meantime, I'm going to go get some dinner. We are back on these motors, okay? We got a mountain to go through. And we got some big boys, man. Those are nice, man. Big nuggets of copper. I'm really excited to split and pull them. We're gonna go ahead and get all this stuff split first. Now, most of this stuff I'm gonna split here, but there is some that I am going to just cut one side, and I think like this is gonna be the limit. Now, eventually I'll have a setup to where I don't know if I'll split, especially this one here. This one got pins in it. See that? So I am going to cut one side, and then I'll pull it with the puller. But like these skinny ones here, I think I'm gonna have a hard time splitting them. You know, this one here I might be able to get. I think that might be even that one, but yeah, I don't know. We'll have to see. Now these ones here, these ones are actually kind of tough to split because they're wound in there, right? And so they're like squeezing this together. When that splitter comes in, it pushes this apart. So it actually has to really force its way in there. I believe these were better. I don't know. We'll split one, but the skinny ones, anything that's real skinny, like 2 inches or whatever, these we're not going to split. You know, there's only a couple of them. We'll have to get a good way of getting them off. I like that. I seen that the way the guy was running the air chisel. I might try the air chisel. Problem with my air chisel is I have that quick release thing on it, and the things are actually stuck on there, unfortunately. Anyway, let's get right to it and start splitting. This whole thing needs to be revamped. I need to be able to drop this on the table. Not even this, because this just ain't working. I need a proper V, like these plates, that is just going to drop in, you know. The reason I have these in here is sometimes the motors, you'll see here, these motors that I'm splitting, all these smaller ones are at a certain size to where it won't fit if I put them in here, right? It just won't fit. And then when I move these out of the way and drop it down in there, it don't have enough stroke to complete it. So we'll just do what we can. Oh man. That's a freaking problem. Yeah, I think this size here, this is where we're gonna have to call it, because that's a problem. And I think the main problem is, here's the main problem. One, this is moving around. It's doing this and letting the thing do weird stuff. I need to I wonder if I should just weld that in there. The problem is, then I'm not going to be able to start. The whole issue with my problem is I don't have enough stroke on this freaking ram. Oh, and then a while back, I was doing something, and this bar, I had it clamped back there, and somehow it got over to the side. And as I was bringing this up, it got underneath the corner. It got underneath the ram. Here, I'll show you. It got in there like this. And when I was bringing it up, it was actually low like this, so I really couldn't see it. When I was bringing it up, it popped that thing off. Those of you who've been around the channel a while know that this thing down here was originally held up inside this cylinder with a like plastic or rubber seal. And when that popped out, I didn't see it. It rolled over here in the corner. This ball came out. So I need to get this back in there somehow, which I'm probably gonna put this here, let it pop it back off. But I'm gonna wait until I have the Y holder, because what it's doing is it's pushing. Actually, I should probably do it now, because it's pushing down on here, and I don't want it to damage that chrome on that cylinder. I mean, this thing was, I paid $800 used off of eBay. It's an $8,000 cylinder when you go look it up at Enerpac. You know, Enerpac is the top of the line when it comes to cylinders and stuff like that. So I just don't want it messing up that that rod. So we got all kinds of problems over here, man. I guess I should do that now, see if I can't get that situated. Okay, show you what's going on here. So this apparently sits in there. Like that. Now what happened originally is that's literally one of these long bolts out of a electric motor. Originally there was like a seal here that looked exactly like a seal that would be inside the hydraulic cylinder. It was just in there holding that in there. And the crazy thing is, I have had this on here for a long time, and I was pulling up on this and picking up big motors and pulling that blade out of them big motors when it was stuck, and it didn't start coming out until like the seal finally got old, like a seal does. It gets old, it dries up. And I was shocked at how much pressure that seal was actually holding. So let's, oh, you know what, I got a shim underneath of that thing. Last time I used a couple pieces of transformer. Might not even do it now that I let me see if I can't get it to pop on without it. Now that it's bent down here, there used to be a little bit of play in there. See, now that whole cylinder moved over. Yeah, see this thing here, there's a track up here. This cylinder will go side to side. This trolley or this carriage is something I built. This press originally had a cylinder like this, but a half the size, 55 ton, up in here, moving, and you can move it around and do what you want. And we like to push it to the limits. There it is. Now that's basically a spring load, like it's a piece of steel, but it springs out and locks in a groove in there. I just have to be careful not to get my hands up underneath, like in between there. That could be problematic. So all right, now I feel safer about that. I'm trying not to damage anything else today. I'm gonna break out the flappy wheel, and I'm gonna grind that back and sharpen that up. Yeah, that's a shame, man. I drove that thing right down into it. Ultimately, I'd like to put this on my milling machine and get it. You can tell they fly cut that. I'd like to fly cut it again. And then looks like they used like a belt sander on the corner or something. I don't know. But we're going to be making our own blades so this don't happen. It's weird how it breaks. It almost looks like it's like layers, you know. I guess they probably hardened the outside of it somehow. I don't know. The guy told me, oh, it's a special process. It's not too hard, it's not too soft. Well, it's chipping. And someone had mentioned in the comments a while ago that they had a machine that had one of these blades, and this is exactly what happened to it. It started chipping. Mine didn't start chipping until I was running it sideways in the thing, and I think I know why. This plate, you can actually almost tell, is curved. When I welded these to it, it changed it. So I think what I'm going to do is have to make this out of a thicker plate, and I'm going to have to heat it up real hot, weld the thing on there, and then like make sure that it doesn't warp. Slowly cool it or something. I'm going to talk to my buddy about that. Because here's what's happening. When I stick it in here, this is what happened. The other day when I was like, man, why is this cutting so crooked? One way it goes in, it's relatively straight. When you turn it around and get it in there, it actually holds the blade crooked. So, and that could be that this thing here is not straight. This was just a piece of F750 truck frame, you know, and I've been pushing on it with this press. Who knows? It's not very thick, as you can see. I need to cut this off, either make a new one or add a very thick plate to the bottom of this, and then rebuild all my stuff more precise to where I'm not going to have problems with it breaking. All right, see if that does any better. Definitely a lot sharper. It's cutting that way. I think I got it the wrong way. Much better. We did come through a couple of them, but I'm okay with that. All right, let's try one of these again. Okay, a couple observations. One, I got to figure something else out here. Two, I think I know where my movement's coming from. So, here's what's happening. As that thing is coming down, this is rocking. This whole thing is going like this. And this is... I got to figure a way of getting rid of that. It's a combination of things. It's the bottom is not really holding it well. Okay, and then as it starts going in, it's wanting to move. This thing needs to just come up. I noticed that when it starts, you can see when it starts, it gets in there and it's doing a great job. But as it gets about halfway through and it's starting to put more pressure, it starts walking. It starts walking that way. And what's happening is the blade is doing that. This whole thing is... This whole thing is rocking. Now, when I built this originally, I tried to build this with as tight of a tolerance as possible. I think there's like less than a 1/16 of an inch of gap in between, like here. And I think I later went back and actually shimmed it up even more. But here's something that I believe I'm going to have to do, and I've thought about this for a while. I'm going to have to either take this off and redo it to where I can put like what's that really tough plastic? Nylon. I used to have nylon, big sheets of nylon, 1/2 inch thick nylon, or it was some type of plastic, right? Real tough, durable stuff. They actually use it. I want to get the same plastic that they use in booms for like a telehandler or a bucket truck. They have these. I'll talk to my buddy and see where he got them things. They have replaceable plastic things that the metal rides on the plastic instead of metal on metal, and they're replaceable. I'm gonna have to get something like that and somehow modify this, or just build a whole new I think I'm gonna build a whole new carriage, and I think I'm just gonna have to build a whole new press at this point. What I think this press could be used for is the holding those down and pulling. I think I'm going to revamp this for the second operation and have it dedicated to doing that. And then I'm just going to have to build a more precise, way more heavy duty. I mean, after cracking that big 1/2 inch thick cast iron case, the 100 ton did it. It stretched the things, but I'm thinking I need 200 tons. I'm thinking we need like all the power, all the pressure, all the tonnage. I mean, 100 tons is nothing to sneeze at, you know, but I need a press that's just going to destroy stuff effortlessly. Like, it's not even going to hesitate. That's the problem. Like, when you're building the pressure and building it and slowly building it, and then it gets to the point where it breaks, it's explosive, it's crazy. But like, if I had this thing come down really fast and it just didn't stop, it wouldn't be as violent of that explosive decompression. It would just blow through it in one shot, you know, quick. I mean, I'm sure there'll be some explosions in there, and we're definitely that. I mean, that's nice. I feel okay standing behind that, but that's not nearly thick enough. I have that high impact hockey arena glass. It's 1/2 inch thick. We're going to make a shield. I'll probably have a bracket on here that I can lower and raise the shield up. We'll have to get rid of the hydraulics on this side. You know, we're just going to have to build a. We're going to need a bigger press, and that's it. And we're going to have a way of. The press that I seen, the guy had I-beams. His thing was wrapped around the I-beam, but also in the middle of the H-beam, he had a cylinder, almost like a cylinder from a ram, and he had guides, so it could not move. And we might have to do something similar. We're gonna have to step this up, and we gotta have this. This is just something I threw together to start doing this. We're gonna have a proper V, right? A proper one that'll just drop in and locate itself every time, and maybe have like a, you know, something a lever down here that'll lock it from under the table, and then I can lock going forward. I can have all the jigs, whatever I want to do, because this is just the start. Like the press that I seen that I'm trying to replicate, I mean, the guy probably had 10 different things he was putting in there to do all kinds of different things, you know. And yeah, so let me I'm gonna see if I can't bring this up. Let me see how far we are. Oh, I must have popped the breaker. I gotta see, because I'll tell you what, when that started out, you could see it started out nice, and then this thing started walking. So I'm gonna actually, you know what? I'm gonna see if I can't shim this with something over here and get it. I'm pretty sure I stuck some steel up in here one time. Maybe it came out. Yeah, I did right here. You know what that is? Right here. You know what that is? I believe I shoved one of these down in there. Maybe I can get this on the other side or something. Oh yeah, you can see. Or whatever this is, I shoved it in here. I shimmed that up so it doesn't rock back and forth, but maybe I didn't get the... It's something. Oh no, you know what that is? I know what that is. That's that unistrut stuff. Yeah, and it still has side to side. What I need to do, well, I don't know. To quickly get rid of movement, I could like cut a notch or actually weld something here with a plastic thing where I can just tighten it down and take that slack out of there. Because this thing needs to come up and down straight. Like this is problematic. That's probably why, one, I broke my tip off, and I'm doing that. But even the real deal machines that they sell this blade for, you know, they get cracks in them. I don't know, man. It's work in progress. I'm going to see if I can't find a shim to raise this up a little bit. Maybe we can get them to split in one stroke. I'll tell you where we're going, right to the scrap yard. Dancing. You ever seen your copper dance before?